So we're live from the iTelescope.net Observatory in Siding Spring. It's great to be with you today. We've got an amazing weekend of activities here. I'll just get my laptop set up. I'm going to welcome our very special guests today, Dr. Pamela Gay from Southern Illinois University, Edwardsville, and of course, well known for her citizen science work with CosmoQuest.org. And also with me, down on, so we'll say hello, Pamela. Hello. And also with me is Neil Shaw, who's one of the affiliates at iTelescope.net here, and his pride and joy is in the background behind you. And if Neil just raises his right hand like this, we'll see T27 in the background there. That's great. So, so thanks, Neil, and welcome. So it's Pamela's first trip to Siding Spring. She's been to Australia, I think, 3 or 4 times, doing the, fly in, stay in 5-star hotels, present your wealth of knowledge to paying attendees at various science events, and you've never actually got out of the capital city to see Australia.
I haven't, and in fact, this is one of the first trips. Sorry, we're trying to figure out how to do this where we're all sharing one microphone. This is actually one of the first trips where I've had truly amazing hotels, and that's because of iTelescope. So normally I'm flying in, dashing, doing mad things, flying back out without any chance to breathe or see anything. And I've actually seen kangaroos this time. But more importantly than kangaroos, I'm in a room filled with so many telescopes that I could not capture all of them in one panoramic photo. And I'm going to have to come back with my planetarium lens later, because only with a full 186-degree field of view will I be able to capture all of the awesomeness that is in the iTelescope shed out here at Siding Springs Observatory.
So, so thanks for joining us. It's been great. A lot of the team on the mountain here haven't met you before, and it's great to have you in Australia as our guest, and to be part of really what is a very special weekend. We have the Siding Spring 50th anniversary open day. And as we look, there's red ribbons being tied around the AAT telescope up there for the 40th birthday party of the actual Anglo-Australian telescope, which is going to have a cake ceremony sometime over the weekend up there as well. And so we're expecting several thousand people on the mountain here tomorrow for the open day, and a very special event this afternoon, which we will carry live, probably without a panel, but just as a single video feed this afternoon, the dedication of this new iTelescope.net Observatory here at Siding Spring. So it's taken a little while to get to the point where we can actually have a ribbon cutting ceremony, but as you can see, the observatory is nearly full, and it's a real tribute to all the hard work that's gone into that over the last 18 months. So, and Neil, I'm going to cut across to you for a sec. Neil is one of the affiliates at iTelescope here, and Neil owns T27, which is shared out across the network to our members. And Neil's had a great passion for astronomy, and I believe is studying, you've done your Masters, I think, and PhD coming on the horizon eventually. And yeah, so, and Neil's got quite a passionate story to go with his telescope about who has inspired him in his astronomy journey. And I know Pamela also is doing a lot of research about what motivates amateurs and people to invest of their own time and energy. So we're going to talk about a couple of these things today. So let's go to Neil first and talk about the Brunel Cannon-Leavitt telescope that's going to be commissioned this afternoon.
Right, thank you, Peter. Yes, I'm very proud to actually have this beautiful telescope, 27-inch plane wave telescope. It's a fantastic instrument. Potentially I might use that later on for my further academic aspirations. Yes, I've completed my master's, and that was a bit of a tough one right now. But PhDs over the horizon, and potentially may use this telescope for such endeavours. However, I'm very happy to actually have the BCL telescope, so the Bernal Cannon Leavitt telescope, not necessarily letters in those orders, but basically these are three great women who've actually made some fantastic contributions to astronomy in the past, which we're still using to this very day. So, and obviously Jocelyn Bell, she's still with us, thank goodness, and has made a fantastic contribution way back in the 60s, as you probably all know, with pulsars and other contributions, but those early discoveries have completely changed and revolutionized the way that we look at astronomy nowadays. And certainly Leavitt with the Cepheid variables and therefore the ability to be able to actually work out distances for the first time with some sort of accuracy. And of course Annie Jump Cannon, who gave us the sort of stellar classification system that we more or less still use today. And these are really important contributions which haven't necessarily been up there and highlighted in a way that perhaps if the male counterparts had discovered those, maybe there would be different, we would be talking about those guys a little bit more. But so I dedicate this particular telescope to those three ladies who have made fantastic contributions. And throughout my studies during my masters, their names cropped up with the regular monotony when it actually comes to the study of distances and stellar classifications, but yet they're nowhere out there really in terms of the profile isn't as perhaps great to say somebody like Hubble, who relied on some of these results, these early results, in order to make his fantastic discoveries about the expanding universe, and no longer island universe. So it's fantastic. I've invited Pamela along with iTelescope to actually do the inauguration on this telescope, and it's a just and fitting person to do that, especially with all her outreach activities, and so I'm very proud and honoured that she's accepted that task for me today. And now over to you, Pamela. And
we rewarded it by making us spend 15.5 hours on a plane. So just a little station break here. We've got the Q&A app open, so you can put any questions you have, any questions about women in astronomy or citizen science or what's going on here. Feel free to put a question into that feed or on the event page. We'll pick those up in a little while. But Pamela, the story that Neil's just shared with us about these famous female astronomers, as a woman in astronomy yourself, that's obviously very passionate for you. And I understand some of the backstory behind these women and the great work they did is really quite fascinating. We're going to cover that off for us today.
Yeah, it's really kind of amazing. Sorry, there's a very friendly flying insect in here with us. It's really kind of amazing to look at the stories, particularly of Henrietta Leavitt and Annie Jump Cannon. These are two women who came from fairly affluent families. They were extraordinarily well educated in a time when women didn't necessarily go to college as just the thing to do. And both of them, for a variety of reasons, were considered unmarriable. And so they took advantage of this, what others would consider a flaw. In Henrietta's case, she was hard of hearing, had health problems, and her looks were critiqued. With the case of Annie Jump Cannon, she had scarlet fever and lost her hearing as well. And so these two women threw themselves headlong into their passion for astronomy. Annie Jump Cannon also had a passion for photography. And they took this astrophotography, this pleasure in physics and mathematics, and took up positions that were initially, they did the work and got paid nothing at Harvard College Observatory. And
after, that would never happen today.
And after proving themselves, they were able to earn between 25 and 30 cents an hour. But they went on to define all of the things that we use as starting points for stellar astronomy. Jocelyn Bell came along half a century later, and she continued to revolutionize stellar astronomy. For her, it was the discovery of pulsars, of these ticking clocks of our universe that we can use for so many different purposes, from astrometry to timekeeping to proving our theories of general relativity. This was discovered also by a woman. But the thing is, all of these discoveries, in the moment that they were made, the credit didn't go to the woman. The credit went to, well, the universe has this awesome thing, and it came from this institution. And while we talk about the Hubble constant and Hubble's discovery of the expansion of the universe, we don't talk about how it was Henrietta Leavitt's work that made what Hubble did possible. And we're starting to right those wrongs, as today we see people renaming it as the Leavitt period luminosity relationship, as people move forward to acknowledge that it was Annie Jump Cannon that took two convoluted spectral systems and turned it into one that was unified by the scientific concept of the hydrogen bomber series. As well, we turn to Jocelyn Bell Burnell as a living leader who's continuing to do amazing science today. And this is just one awesome step in acknowledging the work of these amazing women in science.
Yeah, so there's a lot of history there, isn't there? And I know from the American Association of Variable Star Observers, where I think we've all been members of at various times. You know, some of that, you know, legacy lives on there as well. So, great. So, how are we going for time? Have we got any? Let's just check. So, I just thought I might do a little scan of the observatory here. We've got a couple of the big plane waves. That's just my battery. It'll work with that. A couple of plane waves here. The 17-inch, the 20-inch plane waves, and this is the iTelescope observatory. There's a panel here, sitting here in the nice sun this morning. So, Neil, do you have any questions?
Well, really, I wanted to really kind of encourage young people in particular to get involved in science, and certainly astronomy. Any of the telescopes you feel that you can make a contribution with using. Obviously, each telescope has its particular attributes and characteristics, but I would really strongly encourage you to get involved. Do your science and do your physics. Above all, have some fun. You can actually do it. Just give it a shot, see what you feel about it, and you know, you never know. There's a lot of stuff that's out there that remains to be discovered. It just requires an inquiring mind. It requires a bit of energy, but an inquiring mind's a good thing. It's a healthy thing. It's a healthy thing. And you know, we'd like to share some of our enthusiasm with you. And but we need, of course, young blood, young enthusiasts coming up to take over the mantle, carry on the baton for science, and carry on making discoveries. There's millions of out there. It's so much stuff out there, and this is a pretty exciting time to be around scientifically wise. There's lots of technology out there which make things far easier than they may have been in certainly Annie Jump Cannon's time. You don't have to be a human calculator. You can actually do all sorts of science. But just having, excuse that fly, there's lots of stuff that you can do fairly simply with modern technology, but it just requires good ideas, a bit of enthusiasm, and you can do it. So I encourage you all out there, get involved with citizen science type things, and Pamela, of course, is a very good one and very good exponent to talk about citizen science and the kind of possible projects that you can get involved with. And you don't need to be a mathematician or an Einstein or anything of that nature. You just need to maybe jump onto maybe, I don't know, CosmoQuest or something like that, bit of a plug there. And there are others, but basically get involved in citizen science. You'll be taught how to do things, and you'll build up your foundation of expertise and see whether you like that sort of area of study or science, and just get involved. It's very easy, just requires you to be enthusiastic, get on there, give it a shot. You've got nothing to lose. Science won't hurt you.
Yes,
well,
that's right.
it may cost a bit sometimes, but I mean, it won't hurt you.
So the great story right over my shoulder here, which you can see here. This is T31 on the iTelescope network, and T31 is a 54 square arc minute with a very sensitive camera. And back in, I think it was March, April, June, might be, yeah, asteroid 2014 HQ124 was picked up in the morning sky coming straight out of the sun by Dr. Amy Mainzer of the NEOWISE program, and I think the team there. And one of the good parts about iTelescope is that, you know, if you're submitting data to the Minor Planet Center and using these magnificent telescopes, you kind of get known a little bit, and Amy was aware, and out through some of the lists of the forum, there was an alert sent out from Lance Benner, who wanted to pick up this particular asteroid and get radar view on from Arecibo, and they need signal to noise to get a good radar picture of the asteroid as it's coming through. And because the uncertainty of the path was still quite large, I worked with Amy Mainzer to grab some extra data from this telescope right here, and out of the 124 data points that we used to develop the ephemeris to the point where it was accurate enough to get the Arecibo to track it and get the images as beautifully as they did. It was stunning radar images of this asteroid. We were able to use this telescope. 47 of the 124 data points that were used to get that track improved came from this telescope right here. So it wasn't just me, there was a few other iTelescope users as well, submitting data to the Minor Planet Center. The data that comes from this observatory here, you know, as a semi-amateur, high-end amateur outfit, 93% of the data submitted here is precise to sub-1 arcsecond in its astrometry, which is absolutely outstanding work. And so if this patch of sky just out here in front of us here, beautiful blue, early morning sky, NEOWISE, a repurposed mission, NASA mission, here covering some of the gaps in the southern sky, picked it up, 380 to 500 meter diameter asteroid coming through at 3.2 lunar distances with only 21 days notice. That's why what we do here is actually important and actually fits hand in glove into the work of professional astronomers. That's what Neil was talking about before. You know, you can be part of real science and real activities that support and underpin the work that professional astronomers do. And these telescopes here, we've picked up Comet 67P at magnitude 21.5.
That's the comet that Rosetta. So Rosetta is going to drop the Philae lander onto, well, not drop, it's going to throw at and harpoon the comet that looks like a squeaky duck. It's really kind of amazing.
Yeah, and Padma, of course, who's tied up with the citizen science engagement on that initiative, was out here in April and spent some time here. So hello to Pamela. I think she was planning to watch today as well. So so we've had her out here at Siding Spring as well. So do we have any questions yet at all? Do we?
We have a couple of comments. We have Michael Jobin saying nice, and Natalia Varinia. Sorry if I destroyed that.
Natalia from Marinskaya High School in Ukraine. Yeah. So, g'day Natalia. We've all been thinking of you guys. Difficult times for Ukraine, and we love the work that you've done with Marinskaya High School and all the great team of kids there. So thanks for joining us today. It's great to hear from you. Yes. So, and that's no comments, further comments at this stage. So do you have any questions now?
I was going to really talk to Pamela really about what her experiences have been with nowadays with the young scientists or wannabe scientists, and certainly the youth trying to get involved in astronomy. What's your experience as you travel the globe in these 5-star hotels? I mean, what's your first class? When you land on the other side, do you find that there's a lot of enthusiasm, sort of groundswell of people who want to actually uptake, the kids who want to uptake astronomy?
So I'm laughing so hard at the concept of 5-star because we put all the money we can into doing teacher professional development, into resources for teachers. And so I was, for instance, in Moscow a few weeks ago, and Rosa Dorn and I were crammed into a 200-foot room, sharing a bed, so in the basement of a kind of squirrely hotel that was probably 2 stars on a good day. And that's the thing, is when you want to dedicate your time to education, you want to go so many places and do so many things, and the only way you can do that is to say, I'm going to give first priority to making sure the teachers have it awesome. And so as we travel the world, we're meeting these teachers, and all they want to do is figure out, how do I get my kids engaged in science? And no matter where we go in the world, they have the exact same problems. They have too much oversight, where their school system is saying, you have to teach this, this, and this in this way. They don't have enough technology. They have overcrowding. But at the same time, the best teachers everywhere we go in the world are willing to put in their personal money, their personal time, to go over and above to make sure their kids have access to resources like iTelescope, the Fox telescope. And what gets me is the kids who then, their lives are changed. They are getting involved in observing variable stars, in searching for supernovae. Tim Puckett has done amazing work engaging kids. iTelescope has done amazing work bringing in school groups. And over and over, we end up being joined by kids during our hangouts. My favorite is Callum, a little kid in New Zealand outside of Christchurch. He sent us some of the most amazing postcards of what happened in the earthquake there, and then tuned in to get questions asked and answered, because even though his local observatory had been destroyed by an earthquake, his enthusiasm hadn't waned at all, and all he wanted to do was learn more and do more. And so we leverage everything we can to get as many places as we can to open doors for learning.
That's a fantastic story. So the earthquake may have destroyed his observatory, but it couldn't kill his enthusiasm. There you go. That's dedication for you. And I did want to make one thing very clear. Annie Jump Cannon did not invent the Hotel Stellar system, okay? So if it's a 5-star system, it was a different thing altogether, right? But yeah, that's a really great story. And I guess, Peter, you have sort of similar stories, I guess, in your exploits in this sort of area.
Yes, well, and it's great to have Natalia on the call today, because she's been part of that, and I know Maxim, one of the students she was working with, made a number of new variable star discoveries, and used that as part of his progression through to university. And it was kind of a lump in the throat moment. Here's people all over the world you've never met who are part of our community here at iTelescope.net and really are making amazing contributions to science. it's quite exciting. We've worked with a school in Perpignan, France. I've worked with Yarra Valley Grammar, where my kids go to, and we've did a unit of work with the Target Asteroids program at Arizona University, and we're the only high school in the world to film the Juno probe as it was going past Earth during the NASA government, during the government shutdown, when NASA sort of were on minimum staffing levels for a couple of weeks. So, and that was exciting to walk into a classroom and say, you know what, we've got a problem, and you know, there's a variable star that's you know, 1 hour above the horizon in New Mexico, and it's just popped up by 1/3 of a magnitude, and they're getting nervous. Someone's got a cosmic origin spectrograph session booked. You know, you can't point $1 billion spectrograph at a variable star and not know how bright it's going to be. That's not acceptable. So they always do a go no go decision. And we walked into a classroom one day and said, guys and girls, we've got 40 minutes, and we better nail this. And to see the excitement on their faces and the challenge of having to solve a problem like that. I mean, and as I was saying to Pamela last night, you know, any kid who can play Minecraft can hunt asteroids and observe variable stars. You know, they have keyboard skills, and you know, we talk a lot about the Internet of Things. There's a lot of things in this shed here today. They're all connected to the Internet, and part of, you know, astronomy in the cloud today. It's, you know, it's right on the cutting edge of the frontiers, and to have kids engaged in that process and really you know, in the classroom, they can drive the telescopes from their iPads. You know, they can do all sorts of crazy things that, you know, when I was a 15-year-old kid out in my backyard at 1 o'clock in the morning, meteors seemed crazy. You know, who would, you know, back in, you know, 1975 maybe, who wanted to know that there was a kid in the backyard, you know, counting meteors? You know, who could I tell that there was someone in their backyard counting meteors? You know, but the astronomy as a pursuit of the lonely astronomer on the mountain, which is what I call astronomy 1.0. The astronomy at the eyepiece, still very valid and important work today. But now with the internet and social media and you know, Pamela, who has a following, you know, of 500,000 people on Twitter, and you know, signs autographs at Cosmo, at Comic-Con, and you know, so the pathway for a young person into astronomy today and what it can bring them is no longer just the lonely person at the top of the mountain. It's you know, the person who's socially engaged, who has, you know, a science agenda, who can, you know, study science goals that are still filling in jigsaw pieces of everything we don't know. And so, you know, that's what gets me passionate about it. So my telescope's not in this shed. Mine's in New Mexico, and it was one of the early, it was the first half-meter plane wave, and you know, I don't use it a lot. I actually use some of the ones here even more than I use my own telescope at the moment, because it's shared across the network. So, but collectively, you know, we have skill sets, you know.
And we're starting to get questions.
Yeah, and Neil's quite interested in galaxy evolution kind of stuff, and the intergalactic void, I think you were telling me the other night. I have a very short attention span. I like to track things that are moving, and you know, you know, if there's something exciting happen, I'll jump on it and make sure there's really quality data. So across the suite of skills that we have as amateur astronomers, everyone has a piece of the puzzle. That's really good. So. Yeah.
Yes, thanks, Peter. In terms of areas of study, certainly my own personal preference is things on the cosmic scale. And one of the projects I was recently looking at was to do with calculating the void function. You know, there's the holes in the fabric of the universe of mass at the large scale. So, you know, how dense or how void is it? and how might that possibly relate to the evolution of the Hubble constant over time, and possibly different parts of the universe? Who knows? I mean, we just don't know. So the more, the old adage about the more you know, the more you don't know is so true. You just discover things which either throw you, confirm things, or just open up a can of worms for more questions. And of course, this is the whole point about theories. Theories are good for the moment, maybe so far, but they've always got a sell-by date, maybe, or an end date that's possibly indeterminate, but there is one somewhere. And so the number of projects that are out there that any one of us can actually study is just too numerous to mention, and so I feel spoilt for choice, really. I just need to live for 1,000 years so I can actually go and do them all. But clearly there are some areas which you may find on a personal level more interesting than others, and that's the whole point of maybe starting out on your voyage of scientific discovery, maybe early, or your enthusiasm. Find out what really makes you tick in certain areas, and then just go for it. Only do it if you enjoy it, and that's a really fundamental tenet for success. Your best outcomes are diverting your energy into areas that you've discovered. Actually, I like doing things on a cosmological scale, or I like classifying separate variables, or looking for supernova or something, or asteroids. I mean, there's just the whole area of possibilities for study are just too numerous to mention. So really, don't feel that you need to go down one particular alley and actually, it's only about stars or something. There's just lots of it out there, and there's lots of physics to be discovered. Actually, whilst there's one physics in the universe, in this current one, so they say, we've only really been studying physics in a proper coordinated way for maybe a few hundred years, really, maybe 300 years, and there's lots more out there which we don't know about. And of course, the classic dark matter, dark energy type conundrum, of course, is one of those more topical arrangements whereby we don't seem to know 90% of the energy content of the universe. So it's like, well, how on earth how can you miss that one? Were the astronomers caught sleeping at the telescope? I don't know. But clearly, those kind of things are out there, and imagine in another sort of 100 to 200 years, there's things that will be discovered by then will make us look pretty primitive now. So there are other things out there, other physics that remain to be discovered, and young people have great ideas, new ideas. Perhaps maybe some of us a little bit long in the tooth may not have possibly thought about, and you need fresh minds, fresh enthusiasm to sort of break open some of these old ideas, perhaps, or really look at it in a different sort of way. And this is your opportunity, kids. Get out there, go and do it. Pamela, what do you think?
I think that you're really correct. We're at a point in time where we have an amazing theoretical understanding of our universe. We understand that we have come from a Big Bang, that the universe is expanding, that it actually accelerated apart, and we understand the basics of geometry, of relativity, but our ideas are incomplete. We still are working to understand the insides of black holes. We're still working to understand how to merge gravity in with the other forces. There's so much left to be understood. We are still trying to understand convection at a detailed level, and that's how your lava lamp works. It's an amazing universe with so much left to finish understanding. But what's amazing is with science, we do have the ability to understand it. And I see that we have questions coming in that I can't answer, but I can ask these guys.
Well, we're lucky that another doctor just wandered in, so I might vacate my chair and hand it. So
well, so let's start with answering the, will it be possible to get access to this observatory, and what's the giant light bucket for?
The giant light bucket. Well, yes, so iTelescope.net is a community of users who share these assets. I use assets because I'm putting my ITIL sort of IT service hat on, but we talk about in IT services, we talk about improving capability and reducing constraints, and that creates value. So what I see here is capabilities of doing astrometry, photometry, those kind of basic competencies of science, and then reducing the constraints. So not everyone has the disposable income to afford the $9,000 camera maybe hanging off the one there. So as a community, we have subscription accounts where people can join and just put in, everyone has an eccentric hobby. Some people, buy racehorses, some people buy fast cars, some people buy boats. Bring out another 1,000. That's what it stands for, boats. So as a community, you can have a subscriptional account of $90 a month, and we have a starting account where you can log in and try and take some images and just get familiar with the systems for free. And you can then upgrade to a subscriptional account, and that resource collectively across the whole network and the 15,000 people we have as members, and several hundred that are active every week. That sort of creates the collateral as a not-for-profit that iTelescope is to support this network. So that's the answer to that question. Anyone can join. Just as long as you have an email address, and you can log into an account and set up an account on the network. You're more than we'd love to see you.
And Tim Tuck is asking, what's the magnitude of CG67P now?
Last I photographed it, it was still around 22. I think because its position with regard to the Earth was actually increasing, even though it's getting closer to the Sun and brightening. So, it's going to be very interesting over the next couple of weeks to see what goes on there. So yeah, do you want to take another question? I might see if Amanda's around. We've got Dr. Amanda Bauer has just wandered in, so I might hand over my chair to her and let her talk as well.
So the next question I think is for Neil, and that's what is this? Trying to look over. What is this giant light bucket behind us going to be used for? This is your new 27-inch.
Right. Oh yes, my new toy. Well, of course, this is a shared toy, and really, as you quite rightly point out, it is a 27-inch light bucket, or roughly 3/4 of a meter in metric terms, light bucket. It's mainly, I want to use it particularly for galactic type study. Now, this is pushing it a little bit, but I'd like to do some studies on a galactic side. But anything really that actually requires vast amounts, or at least long time light gathering capabilities, which will sort of distort things less, but produce a better signal to noise ratio for light, for objects emitting light there. But essentially, for me, it's more on a galactic scale type object. So that's what I'm going to be using for, and anybody else out there who wants to do that as well can do it as well, use it as well. The CCD is a pretty sensitive CCD. It's I-9000, was it 90,000? This quite easy in that particular model, but that's got a pretty good efficiency ratio, and across pretty much the bandwidth of the spectrum. So I think maybe not so much on the infrared side, of course, but it's good enough to actually give some values that are be very useful on a scientific basis. So comets will be a pretty good thing as well. Anything that requires a bit of fine detail, that'll be pretty good. Yeah.
So just joining us is Dr. Amanda Bauer, and she's on the computer that has all the controls, so I'm going to reach over and point the controls at her. You are a 5-year research fellow at this observatory, and you've got your fingers in all the science. Can you give us an overview of what all Siding Springs is used for?
Yeah, so I'm at the Australian Astronomical Observatory. I am a research astronomer and the outreach officer. So we are producing these great videos. We've just come up with a YouTube channel that tells you all about some of the science that we're doing in the spectroscopy facilities and the telescopes and night sky time lapses and many things like that. We're also using the big 4-meter Anglo-Australian telescope, although we're the Australian Astronomical Observatory. It's all a bit of a mouthful. So the AAO operates the AAT, so that's the big 4-meter telescope here. That's the biggest optical telescope, and we are looking for trying to map out the entire galaxy, so what kind of stars there are and how they move and what the dark matter looks like. We're trying to find dark energy through different projects that are looking at distant supernova. We're searching for planets. We found about 40 exoplanets with some of our instruments. We just commissioned a very new high-resolution spectrograph called Hermes, and on and on and on. So got our hands in a little bit of a lot of the universe.
And you guys are in an amazing position down here where there's just not as much coverage of the southern hemisphere, and so from your position down here you can tweet out science results as astropixy that we're not going to be able to see from all of our northern hemisphere telescopes. What's it like to get to move down under with cool toys that others don't get to use?
Well, it is pretty fascinating. There's a lot of survey telescopes that have been done over the history using the northern hemisphere. So now we've got this great 4-meter asset that allows us to look at a whole new part of the sky. And just kind of by eye, I like to come out here and use the telescopes and then just look at the large and small Magellanic Clouds, because you can't see those from the northern hemisphere. So we kind of cheat a little bit. I love it down here. And we also get to see right into the center of the Milky Way. So trying to figure out about the supermassive black hole in our galaxy that's kind of hidden from the northern facilities. Unless, I guess, you go to space. You can do that too. But then you don't get the really high-resolution spectrographs that we've got here. So it is an advantage. It's a whole different part of the universe than has been studied by the northern hemisphere.
And when you say we don't have these cool, awesome big spectrographs in space, this confuses a lot of people. You have a Coude spectrograph room here, and this is one of those awesome things no one understands until they step in one. Can you try and explain it without letting people step in one?
So in order to get a really detailed idea of the chemical makeup of a star, or an idea of how a star moves around the Milky Way, you need to be able to resolve its rainbow fingerprint, is what we call it. So you have to be able to very detailed look at the little spikes and wiggles in its rainbow. So you need to know how blue the blue is, or how violet the violet is, and that just gives you so much understanding of I guess just the history of this star, like what's actually in its atmosphere and what kind of gas cloud it was made of, and whether or not its little star next door was created from the same gas cloud, or if it has a completely different gas signature, and then maybe that star formed and it moved from somewhere else across the galaxy. The actual high-resolution spectrograph, you need a very stable room. You need to have lots of distance for these optics to bounce around. So we build entire rooms that are dedicated just to spreading this light out, so we can get the biggest wave, the biggest span of its spectrum that we possibly can.
And what's kind of cool about this is, sorry, I'm trying to switch cameras a little bit. So we've all at various points had either sunlight reflect off of a ring or go through glass, or you've had prisms hanging up, and the light will sometimes spread out maybe 10 centimeters, and you can see all the different colors. With Coude spectrographs, the light actually ends up getting spread out across meters and meters and meters. And you only look at a section of it, or you fold it up and still only look at a section of it. And this rainbow is so precise that you can actually, with some of these, make out not just how much of a particular atom is in a star, but how much of a particular isotope of an atom is in a star. And this starts to get down to the differences that allow you to say, what we're looking at now was formed from this ratio of different types of supernovae, and we can actually start to basically figure out what is the recipe for getting at our sun and the other stars in our nearest neighborhood.
That's about right. Yeah, it's pretty exciting.
So, and I have to admit, I'm also kind of being deeply amused by the fact that this place is infested with wallabies and parrots. So there's just something awesome about doing astronomy someplace where when you're walking around early in the morning, there's a joey hanging out giving you a quizzical look. And so this is a beautiful facility, completely infested with telescopes and wallabies. And yeah, and so Amanda's saying she has a good kangaroo story.
That one. So we sleep in a lodge that's nearby the telescope. So late at night, you kind of have to walk across this field to get over to where the lodge is. And whenever I go outside, I automatically look up. I try to see the large and small Magellanic Clouds and look at the galaxy. So I was kind of mindlessly looking up, and accidentally walked right into a big kangaroo, and then flashed my torch at him, and we both sort of stepped back and looked at each other. Then I walked very slowly around him. Went back over to the lodge, and we went about our business. So it's I guess it's a hazard of working up here with all these kangaroos around. Oh, it's fun to see them, though. I never get tired of that either. The Magellanic Clouds, the kangaroos.
So, Amanda, I've got an actual question for you. In terms of Hermes, maybe as well, but in terms of work at this facility, is there any planetary type work happening here? Do you get involved in that? Because, as you know, that's fairly topical in all parts of the world. It seems you cannot actually open up a scientific magazine nowadays without somebody saying, I've discovered yet another Earth size or near Earth size or what have you. And of course, the sort of radio velocity things are one of the big items to actually cross off your list before you start making any violent claims about finding things. So having Hermes here and other instrumentation, you may be in a really good position to actually confirm or actually just discover these things.
Yeah, absolutely. We have an instrument on the AAT called UCCLES, and that's the one that does most of the planetary searching. So it's led by the University of New South Wales in Sydney. And actually, right now, so tonight and tomorrow night, that's the instrument that's going to be on the telescope. So possibly tomorrow, if you manage to see some of the observers running around, you'll be able to ask them what sort of planets. So to the best of my knowledge, they've actually found about 40 candidates for exosolar planets, and the hunt continues. There's another instrument that's in the works that we will probably build in the future called Veloce, and that's another planet hunter. So you can get the radial velocities from that technology.
So from some of these initial results, are some of these candidates actually pushed out to the amateur community for sort of verification or follow-up, or is that possible, or is it a little bit too difficult at this stage?
I think probably the faintness of these candidates might make it that you need this kind of technology in order to do it, but I haven't followed up with the team yet, so I'm not entirely sure how much interaction they've been having with the amateurs, and I think that's a great topic for me to bring up with them this week when I see them up here. Yeah, that's a great idea. I'll plug them for that, see if we can do it.
And what is the meters per second resolution of the spectrograph?
I don't know off the top of my head. That one, I'm not sure.
So the reason I ask is many of these spectrographs actually have sufficiently high resolution that you can measure the speeds of stars that are moving at the same rate that a human being can walk around. And I just love the idea that I can, in theory, if I'm feeling particularly bored one day, look up how fast a star is moving back and forth because of the tug of the exoplanet going around it, and basically replicate that movement, because stars don't move that much, and our ability to see that movement is that precise. And there's some choreographer out there just waiting to do this as an art project, I'm sure.
Or the Dance Your PhD. Don't they have that? Yes. So some of the Dance Your PhD, you have to come up with a 3-minute thing that describes your results. So I think a planetary discovery is a key candidate for that.
So I'm just kind of in awe and wandering around helplessly in awe. But one of the things that in the process of wandering around big-eyed at all of the telescopes and all of the wallabies that I've seen is this is really a facility that's bouncing back from a horrible fire a couple of years ago. And when we say bouncing back, there's koalas coming back, there's emus coming back, and there's astronomers coming back. And I'd love to hear what it's been like to come back from such an experience.
Yeah, that day last year, January in 2013, was quite a dramatic experience. And I hadn't really ever lived in a place that had bushfires in that way, so I didn't know what the devastation would be like. black trunks on all the trees. But the process of regrowth has actually been fascinating. Being able to see the animals come back, be able to see all of the trees grow this little green fuzz right around the bark, because you get a lot of seedlings that are germinated, or they just are activated by the heat of the fire. So I hadn't seen that before. And there's all kinds of cacti and things around that bloom as a result of the fire that I'd never seen. And now you've got these little barren trees all over these mountains that I'd never seen before, and it kind of looks like the mountains have a little stubble when you're driving up. We commented on that last night when we were driving in. So it's growing back, it's regrowing, it's great to see. It's great that we're able to stay up here now. We're kind of getting temporary facilities for the astronomers to sleep in so we can still do our science. We were only down for about a month, and then the telescopes were back up and operating. So it's kind of full on now, and since that time we've commissioned an instrument. We've gotten some of the members of the Australian government to come up and visit the sites, and this Starfest is planning to be the biggest one. We had a couple thousand people come up last year, but this year I think is going to be even more amazing, especially with Andy Thomas. Oh, so excited.
And you're one of the people responsible for making Starfest happen, from what I understand. And it's an amazing lineup of people that you've brought together. There's astronaut Thompson, there's Brian Schmidt, who's a Nobel laureate, is going to be here, Fred Watson, who's just an all-around awesome guy and science communicator, and Filk singer. You and he are going to be doing duets at the Science in the Pub, and I love how you're combining amazing science, amazing outreach, and doing it in such a creative fashion. How long did it take you to bring together everything for this Starfest?
Well, you know, we take a deep breath after the last one and then kind of start planning again. And it's been getting bigger and better, and there's just such an interesting facility to show off. I mean, this is the only day that we actually open up the full observatory and let the public walk through and talk to the astronomers and the engineers and everybody involved in it. It's the only time during the whole year. So that's really exciting. And then Science in the Pub, and to have special guests. I think one of my favorite things is not only to be involved in the science, but then figuring out how to translate that into something that maybe the public will understand, like what is the depth that goes into building the technology, and from the idea of what kind of science we need to do to the design of the instrument, to building the instrument, and then finally seeing it come through on the telescope and getting the first data and science results. It's a whole huge process that takes so many people, and just people with fascinating skill. I think that's one thing, particularly at the AAO. We've got this 4-meter telescope. It's not the biggest telescope in the world, but we've got really good, innovative people who get an idea and then say, okay, go with it. So we have this instrument now called SAMI. This is a spectrograph, but instead of just one little optical fiber on one star or galaxy, this actually has 61 optical fibers that all look at this galaxy, so you can see how the stars in different parts of the galaxy are spinning around. This was an idea that Joss Bland Hawthorne, who's going to be here tonight at Science in the Pub, he came up with this with a colleague, and then 9 months later, they had built the technology to put on the telescope, and it was observing and collecting data for a galaxy. So it's just an amazing transition from having an idea, having the people to do it, having the freedom to be able to explore those ideas, and then making it happen. So it's so fun. It's such a fun community to be able to work in over here.
And for the people who can't be here live, how can they learn about all the awesome things going on?
We have our starfest.org.au, I think. That's the website. We also have the AAO is on Twitter, so it's at AAO Astro. You can follow me, AstroPixie, and I think there might be another website or something, Facebook for the Australian Astronomical Observatory. And definitely follow along for me and the AAO Astro for Twitter for the next weekend. I would say we're going to be posting quite rapidly. Thanks for having me.
And for those of you interested in catching all the activity, we are tweeting out on hashtag StarFest2014. I'll be posting pictures. I'm sure that Amanda will be posting things as well. And so you should be able to catch all the activity, and there are a number of live Hangouts that we're going to be doing. And we will post links as we get the event pages up and running. And we have Peter back.
Yes, thanks, Amanda, for joining us today. It's great. There's a little impromptu bonus there. It was great. So also this afternoon at 3:30, we will be carrying not a panel type Google Hangout, but we'll we'll have just a single video feed of the official opening of this observatory just for our members, because there's so many of them around the world, and there's an event in my Hangout feed which I've put on the iTelescope.net Facebook page and the iTelescope.net club in Facebook. So if you're wondering, just go to the iTelescope.net Facebook page this afternoon, and I'll be putting the link up about half an hour beforehand so that you can join us, and we're going to have the official dedication of Neil's telescope and the official opening of the observatory, and Brad Moore, our Managing Director of iTelescope, will be here for that as well. So thanks everyone for joining us today. From I think we got a hello from Padma there, so she's watching over wherever she is in the world today, and Natalia, I think, set the record from Ukraine, so thanks for joining us. For all our members and affiliates across the world, we hope you enjoyed this today. It's been really exciting for us to be part of this, and we're still learning all this new wonderful media and the Google Plus Hangout, and every time we use it, it's a little bit different to how we used it before, but it's been good fun today. So thanks, Pamela, for joining us today.
It's really been my pleasure. I'm so pleased to get to be here and be part of the opening of this beautiful new telescope and all the science that's coming up here on the mountain. And it's going to be awesome.
Thank you.
Yes, thank you, Pamela. Thank you, Peter, and thank you, Amanda. I absolutely concur with that, and hopefully we'll catch up with you later on the grand opening ceremonies. So please join us.
So yeah, back here at 3:30 Australian time this afternoon for the official opening of the observatory. So thank you all for joining us. Thanks for the pressing, hard science questions you put to us there, and thanks for joining us today. And that's over and out from iTelescope.net on the mountain at Siding Spring. Thank you.